My goblin. I'm here today with my trusty Type 13 bastard sword by Angus Trim, and I'm going to talk about test cutting so that you'll be more efficient and capable of slaying goblins and protecting Middle-earth. It's also a sport, and in attempting to understand Western martial arts, medieval swordsmanship, we know that we're divorced from actually killing swords. We don't have experience doing that, killing with swords, I should say. And some of our information comes from the wrong places, such as the movies, right? And it's sometimes not accurate. So in order to understand this historical activity and what our ancestors went through and all the struggles they saw, we're cutting a realistic target, attempting to do so with realistic techniques, and this is going to help us understand other things. It's also fun. So there's principles I'm going to focus on. I'm not cutting today, not in this episode. I'm going to just go over the four principles of effective cutting. Let's go right ahead and do this. My sword it's kind of a coincidence that I chose this sword. The length and the weight of the sword is almost identical to your average katana. So I found that I can actually use katana techniques that we've learned from Kenjutsu, Iaido, and so on, and see if they can be applied toward the Western martial arts. There's one thing, of course, this cross guard. If I do some of the techniques, boom, I might gouge myself in the head with this cross guard. I've seen that happen. And I do have a sword that is twice as sharp. It's a katana. Yes, it has two edges. Okay. The first principle is that of edge alignment. If I think of my blade as existing in a plane, the geometric concept, and I'm placing this yardstick on the edge of the blade, or actually on the flat of the blade, sorry, and I'm helping to illustrate all of this is on the same plane, right? Now, having understood this, I also want to understand that the cut is on one plane. I'm not doing this sort of stuff. It's going to be straight. And suppose it's like that, lying on one plane, right? And I want to cut such that the flat of my blade is coincidental with the plane of the cut. Going from here, maybe you can see it better. All the way down, all the way down, all the way up for the rising cut. There's no rotation of the blade. I mention that because if I hand my sword to some yahoo on the street, he may actually do something like, some fancy stuff we saw on TV, and at some point, right, see this? He's actually thinking he's going to cut the flat of the blade. This is not a lightsaber. It's got to go in a certain direction. That's an obvious one. But other people who are involved in what I call sword sports, the SCA, sport fencing, LARP, Boffer fighting, even reenactment combat, they'll know about contacting the target with the edge, but then after they cut, they roll out with the blade. there's a certain rolling motion here, right? And it's not effective. Okay, if you start cutting against a target like this, you'll find out right away. These are going to be flub cuts. Primary concept with these principles is why your cuts are flubbed and how to improve them. And the most common mistake people make is they're rotating their blade through the cut. It is easier anatomically for your arms to move in that position. It's not much harder to maintain it, but it's not intuitive. Again, if I hand this European sword to somebody, they don't have schooling in the actual Western martial arts, and it's still a matter of discussion. But if I bring out a katana and I say, here, use this, that person, no matter who they are, will have seen somebody using a katana in a movie or in a video game, and at some point that might have been advised by somebody who had experience in training in the traditional martial arts with the katana, kenjutsu or whatever. And they'll often be using it correctly, to some degree. So what I'm proposing is that what you know from Iaido, kenjutsu, and other Japanese sword arts, try applying that to a European sword and see how that works. Now my sword, or any object, actually will vibrate in a specific pattern. It's not a random thing. If I strike this yardstick, it will vibrate at a certain frequency depending on the substance it's made out of, its dimensions. And the vibration is always regular. No matter where I hit this blade from, it will have a certain vibrational pattern. We're going to use that to our advantage. Best way with a sword to see the vibrational pattern, all you normally do is hold the sword in one hand, do the cross lightly, and I will take the other hand and bonk this right here. Now I don't think you can see this on the video, but if you observe carefully your own sword, it will be vibrating like this near the tip. Okay, and between the handle and a point around here, you'll see a sort of wobble inside there. It's hard to see, but there's also a sort of vibration on the handle as well. My point is that the spot right about here, we're going to call it the sweet spot, and the vibration is much less there. No matter what happens to it, what sort of impact occurs to this sword, it's going to vibrate much less right here. Why am I saying this? What difference does this make? The impact in this case is your sword against your opponent, or the target. And I know that a lot of sword sports, fencing, SCA, whatever, try to hit with the tip. And that's a habit they get into because it allows you longer reach. You get to get a better chance of getting your opponent, scoring against your opponent, I should say. However, when you use a real blade against a realistic target, that tip is wobbling so much. There's so much energy dissipated through that wobbling that the cut is botched. Can't go much further into it than that, except try it yourself, you'll find out. But if you cut further up here on the sweet spot, much more successful cuts. So two things: if you are keeping edge alignment, maintain the plane of the blade, consistent with the plane of the cut throughout, and trying to cut in the area of the sweet spot. You're on the way, or halfway there. Now, there's a spot here that's precisely defined, but any place in that general area is better than over here. It's a relative thing, really. Okay, let's move on to the next spot. We're going to talk about physics here. Specifically, we're going to talk about moment arms. This is a rattan stick for practice in eskrima. It's maybe, what, 2 feet long, something like that. Here's a big old long dowel that's 4 feet long. What I'm going to do is try to move both of these the same rate, by which I mean they're going to go from one position to the other. That's about 90 degrees, right? And we're going to pretend that movement takes about 1 second, right? So watch this. So the tip of this, in that space of time, had to cover much less distance than the tip of this. So this was going faster. The tip of the long moment arm was going much faster than the tip of the short moment arm, all other things being equal. And bring this to the sword. If I am attempting something like this, that's the length of my moment arm. And the power of my cut, the velocity of the cutting part of the sword is limited by that. If I'm just doing something like this, for whatever reason, it's got a chance of being a failed cut compared to something where I'm actually extending and lengthening my stroke. And notice at the end of this, at the beginning of the stroke, I'm in a posture that's well known to various sword arts around the world. Right. In the Japanese schools, this is Kamai Niran and Poste Falcone in School of Vadi. Other arts name it something else. It's not vulnerable. It looks vulnerable, but it's not. Because without much telegraphing, right, I can cut you in half. Of course, I won't approach someone like this without any preamble. Obviously, you know what I'm going to try to do, and you're going to prepare for it. But if I happen to find myself in that position in the course of a fight, it's easy. And gravity's on my side. We'll go over that later. I'm not doing the cuts today. Anyway, we have 3 techniques that'll help your cut already. Keeping the plane of the blade consistent with the plane of the cut. 1. Number 2, cutting with a sweet spot whenever possible. 3, extending the moment arm. Cutting with an extended arm as much as possible within the realms of tactical practicals. Right? You don't make yourself vulnerable just to make a fancy cut, but you're going to create an opening whenever possible to where you can actually create that cut, make them go down. So these are getting more complicated as we go along. The 4th one's a little bit more difficult to explain. Let's take this outside. So my car is out of gas. I have to push it. I know it's a Prius, and they don't really go into neutral per se, but bear with me. I'm just demonstrating the point here. I'm not going to try to push with my hands. There's never going to be enough strength in my hands to move a car. I'm not going to push with my elbows. It's not going going to work. You can try it yourself if you like. I'm not going to be pushing with any part of my upper body. There's two basic ways people normally use to push a vehicle. One is by locking the arms, making the upper part of the body a somewhat rigid unit, so they're out of the equation, and using the lower part of the body to exert the force. Right. Another way of doing that is just grounding the hips against the vehicle, like that, and just using the arms to stabilize. Either way works. So how does that apply to sword work? You're not relying on these arms at all. They're just aiming the sword. Okay? So instead of just swinging with my arms, and it kind of reminds me of a character from Conan the Destroyer. What is his name? Malak? You know, the Conan and the Black Giant are trying to raise this door, exerting all their might. And here comes a skinny thief. Here, let me help. And he's not helping at all. He's just getting in the way. That's what your arms are doing. You can only generate a certain amount of torque. I don't care who you are with your arms. It's not possible. Use the strongest part of your body. In fact, what we're going to do is use the strongest muscles in your body to create torque, or rotation of your body, and it's powered by your body weight. You've got your whole body weight behind it. You've got the biggest muscles of your body behind it. And that's why you sometimes see people stepping through the cut. You see the arms moving, but it's not the arms doing the work. It's actually the legs, the back, the core, and so on. Experiment with that one and see how it works for you. Well, that's his sandbox. He looks back and says, "What are you looking at?" Hey, Jumbo.